All right, continuing with example 24, starting with question G. This time 5 cards are dealt from a standard deck. We want to find the probability of getting 5 face cards. So again, our numerator is going to be the number of ways we can be dealt 5 face cards. There are 12 face cards in a deck. Order doesn't matter, so this is a combination or a choose 5. And then our denominator is we just need any 5 cards to be dealt to us. So that's 52, choose 5 for 792 over the 2, 5, 9, 8, 9, 6, 0. All right, for H, 5 cards are dealt from a deck. What's the probability of being dealt 5 black face cards? So very similar to the last question, except now instead of all 12 face cards, we just want to think about how many of those face cards are black. There are 6 black face cards. We are being dealt 5 of them. So 6 choose 5 over 52 choose 5, any 5 card hand at all. And that is 6 over the same 2, 5, 9, 8, 9, 6, 0. All right, another lottery question. So in Powerball, there are 69 balls numbered 1 through 69, and they are placed in a machine. 5 are picked out at random. Okay, order doesn't matter. And then there's 26 red balls numbered 1 through 26, and one of those is drawn at random. You got in a pool with your coworkers, and together you purchased 20 tickets, each with a different set of numbers, and you were hoping to win that $500 million jackpot. What is the probability you and your coworkers win? So as in the question on the previous page, you and your coworkers gave yourself 20 different chances to win, okay? But in this Powerball, you need to get a match for all of those white numbers and a match for that one red number as well. So the order doesn't matter. So for those 69 white balls, there are 69. They will choose 5 of them to come out of that container. And there's your multiplication. There are 26 red balls. They will choose 1 to come out of the container again and be the winning Powerball number. And so you have 20 chances out of 292,201,338 different possible winning Powerball numbers. All right, some friends meet for appetizers at a restaurant. The menu has 12 appetizers, 5 of which have cheese as an ingredient. 6 different appetizers are going to be ordered. What is the probability that 2 have cheese? So again, think of what we're talking about here. We're talking about 2 with cheese, and therefore 4 with no cheese. Okay, that's what we're looking at. That's what your numerator is going to look like. Your denominator is just, I need to get any 6 appetizers. So if we're going to deal with the ones with cheese, 5 different possibilities have cheese as an ingredient. We are going to choose 2 of them to order. Again, the order in which you place your order doesn't matter, okay? And times 4 with no cheese. So if there are 12 appetizers and 5 have cheese, the other 7 do not, and you would be ordering 4 out of those 7. And then your denominator is, I just need to order any 6 appetizers. So of all 12 appetizers on the menu, you want to order 6 of them. That will give you a probability of 350 out of 924. Okay, so similar problem, but now it's not just 2 of them will have cheese, it's 2 or 3 of them. So think what has to happen. That would mean you have 2 with cheese, or you have 3 with cheese. But again, if you get 2 with cheese, that means you also have 4 with no cheese. And if you get 3 with cheese, that means you would also pick out 3 that have no cheese. Okay, so you're going to have 2 different scenarios here, and that's over any of those 6 appetizers. Okay, so this first part, 2 cheese and 4 no cheese, that looks exactly like the last problem. That's kind of handy. Remember, our word or is an indicator we should add. And now we need to work on this other scenario. We end up with 3 appetizers that have cheese as an ingredient. So again, 5 available that have cheese as an ingredient. We're going to choose 3 of them to order. And then out of the remaining 7 appetizers, we need to choose 3 that do not have cheese. Out of, there are 12 appetizers, we're just going to order any 6. Okay, probability is 700 out of 924. Again, no need to reduce. All right, last 2 on this page. There are 5 red, 7 blue, and 4 yellow marbles in a jar. We're going to choose 3 without replacement, so we're not putting them back. What is the probability the marbles are drawn in this order? Blue, red, blue. And that's a big and, right? I need a blue and a red and a blue. Blue and a red and a blue. So if we're going to draw a blue marble, there are 7 blue marbles in the container out of a total of 16 total marbles. So I'm going to kind of do my numerator and denominator at the same time. Then I need a red marble. There are 5 reds in the container. And remember, out of those 16, we already took a blue out, so now there's only 15 marbles left in the container. And now I need another blue. So I started with 7. Remember, I took 1 out, so there are 6 blue marbles remaining, and there are 14 total marbles remaining in that jar for a probability of 210 out of 3,360. All right, and last but not least, when you play Yahtzee, it's when you get the same number on every one of your dice. So what's the probability you roll a Yahtzee in a single roll of the dice? So actually, we're going to break this down. I know most of the time if you've played Yahtzee, you like throw all 5 dice at the same time, but let's think about doing it one at a time. So that first die, it doesn't have to be any particular number. If you think of it as rolling that first die, no matter what you come up with, that's the number you're going to have to match on all your remaining die. So that first one can be anything. You have 6 different choices. But once you've seen what's on that die, say it's a 4, now you have to roll a 4 on every remaining die. So you only have 1 choice for the second die, a 4, 1 choice for the third die, a 4, etc., whatever that is. And then your denominator is you still have 6 options on every one of those dice, no matter what. Okay, it can be any 6 of those numbers. Now again, I'm going to take this first 6 over 6 and cancel that out because that's fairly easy to do. And that gives us a probability of 1 over 1,296.